In this section, we are going to have an overview about RFID technology. Topics we are going to talk about are the history of RFID, how does it work, its components, RFID operating frequencies and standards, and then we will have a conclusion. RFID stands for Radio Frequency Identification and is an automated data capture technology. It uses radio waves for identification and provides unique identification or serial number for an object. Today, RFID technology has 6 years old. In 1846, Faraday stated that light and radio waves are part of electromagnetic energy. After a century, in 1948, Stockman invented RFID. And from 2000, RFID became a part of our daily life. Let's have a decade-by-decade look at RFID history. Between 1940 and 50, radars refined and reused. Also, World War II developments resulted in RFID innovation. In the next decade, some exploration regarding RFID had performed and laboratory experiments started. In 1960s, RFID theory has been developed and field tests started. 1970 to 80 was the explosion era of RFID. Tests have been accelerated and RFID has been started to implement. Commercial applications have been initiated in 1980s. In the last decade of 20th century, RFID standards have been emerged and became a daily life need. But what is RFID technology? RFID is a method of remotely storing and retrieving data that is based on the detection of electromagnetic signals, and radio frequencies are used to capture and transmit data from or to a tag. How does it work? The reader emits a radio signal. The signal activates the tag and the data is read or written. Data information is sent back to a reader. Each barcode has 4 sections. The first part is header. It's a version of EPC and could cover 256 possible combinations. The second part is EPC Manager that could cover more than 268 million combinations. Object Class could cover more than 16 million product type and serial number could cover more than 68 billion number. This unique identity code is the base of reports which contain related information for a particular material. RFID has 3 basic components. The tag with an antenna, called a transponder. The reader with an antenna called an interrogator. A host terminal, which is a middleware computer and software. The first component is a tag, which is a transponder which receives a radio signal and in response to it sends out a radio signal. An RFID tag has a protective printable face stock, then a layer of adhesive, then the RFID inlay, then another layer of adhesive, and finally a removable liner. Tag is a device used to transmit information such as a serial number to the reader in a contactless manner. Tag contains an antenna and a small chip that stores a small amount of data. A simple silicon microchip attached to a small flat aerial and mounted on a substrate. The whole device can then be encapsulated in different materials dependent upon its intended usage. The finished tag can be attached to an object, typically an item, box, or pallet, and read remotely to ascertain its identity, position, or state. Tag can be programmed at manufacture or on installation. Tag is powered by the high-power electromagnetic field generated by the antenna. The field allows the chip antenna to reflect back an extremely weak signal contains the data. Tags have three classifications: passive, active, semi-passive, or semi-active tags. Passive tags obtain all of their energy by some method of transmission from the reader. Alert the tag to communicate through a reader when the reader signal is detected by the tag. Communicates without battery, derives power from the reader's electromagnetic field. Active tags use an onboard battery to power communication, a processor, memory, and possibly sensors. Catch the attention of RFID reader by sending out a signal. Function with battery power, can be detected over a greater distance. Semi-passive or semi-active tags use the power to work IC to monitor environmental conditions like temperature, by communicate by drawing power from the reader device. Each type of tags has some advantages and disadvantages. Passive tags advantages are the tag functions without a battery. These tags have a useful life of 20 years or more. The tag is typically much less expensive to manufacture. The tag is much smaller and have almost unlimited application in consumer goods and other areas. But this type of tags disadvantages are the tag can be read only at a very short distance, typically a few feet at most. It may not be possible to include sensors that can use electricity for power. The tag remains readable for a very long time even after the product to which the tag is attached has been sold and is no longer being tracked. Active tags advantages are that these tags are more reliable, has higher power levels, and more effective in RF challenge environments. Active tags disadvantages are the tag cannot function without battery power, which limits the lifetime of the tag. The tag is typically more expensive. The long-term maintenance cost for an active RFID tag can be greater than those of a passive tag if the batteries are replaced. Battery outages in an active tag can result in expensive misreads. Here we have a comparison between active tags and passive tags. Specification. Active tags power source is inbuilt battery, but passive tags derive power from the electromagnetic field generated from the reader. Active tags power is continuous, but passive tag power only when found in the field of the reader. When using active tags, more tags can be read simultaneously. But when passive tags is being used, less tags can be read simultaneously. In challenge environmental specification, active tags has better noise immunity, but passive tags are subjected to noise. On the other hand, active tags have long range of communication. Their data transmission speed is higher and has more data storage. Active tags also have lower required signal strength from the reader to the tag. Their availability signal strength from the tag to the reader is higher and are able to install another sensor. They are more expensive and their lifetime is limited because of the battery and are heavier than passive tags. There are three types of tags regarding recording information. Some of them are read-only, some of them are read many times but write once, and some of them are read and write. To select an RFID tag, there are some criterion to consider: frequency range, memory size and read-write, read range performance, shape, form, environmental conditions, standards compliance. Many diverse factors will cause read range different. For example, operation frequency, reader output power, tag antenna size, reader antenna size, active tag or passive tag, reader position, object interference, other RF device interference, and so on. In this slide, you can see different types of tags and its elements inside the tags. As indicated in this slide, RFID tags can be manufactured in several different shapes and sizes, depending on the type of application in which they will be used. And here we have some shapes of passive tags are using in the industry. Smart tags have three parts. One part is readable for human, the other one is readable for barcode readers, and the other one is readable for RFID readers. What is a reader? An RFID reader is a device that is used to interrogate an RFID tag. The reader has an antenna that emits radio waves. The tag responds by sending back its data. The reader has two basic components: a scanning antenna, a transceiver with a decoder to interpret the data. Reader or interrogator has some characteristics. Consists of transceiver, antenna, microprocessor, stationary or handheld, weatherproof or industrialized, multi-frequency readers. Readers powers passive tags with RF energy. Reader range is dependent on broadcast signal strength, size of broadcast antenna, size of transponder antenna, the environment, such as metallic and liquid. Different types of readers are illustrated in this picture: handheld terminal readers, handheld reader or writers, handheld reader or mobile computers. The difference between the devices illustrated in this slide from the previous slide is these devices are only readers. Reader's antenna could be fixed or tunable, stationary or handheld, weatherproof or industrialized. The third part of an RFID system is middleware or host terminal, which consists of network, hardware, and software, which provides reader connectivity to other systems on the network, translates the data, and transmits it to other applications. RFIDs are working under different frequencies. Low frequency ones working between 125 to 134 kHz, most commonly and used in access control, livestock, pallet tracking, automotive immobilizers, animal tracking, and asset tracking. High frequencies are working on 13.56 MHz, used where medium data rate and read range up to about 150 meters are acceptable. This frequency also has the advantage of not being susceptible to interference from the presence of water or metals. Ultra-high frequencies working between 433 to 956 MHz offer a longest read range of up to approximately 3 meters and high reading speeds. Since ultra-high frequencies has the range to cover portals and dock doors, it is gaining industry support as the choice frequency for inventory tracking applications including pallets and cases, and microwaves working between 2.45 to 5.8 GHz. Still highly experimental, chipless technology. There is a review about different types of tags. As illustrated, ultra-high frequencies has the longest read range among all other types. Low frequency and high frequencies should use passive tags only, but for ultra-high frequency and microwaves, active or passive tags both are applicable. Low frequencies are good for access control. High frequencies are good for item tracking. Ultra-high frequencies is suitable for pallet tracking, and microwaves are suitable for asset tracking. Low frequencies are the cheapest types, but slower in reading speed. Their energy absorption is less than the other, but energy efficiency is higher than the other types. As presented, low frequency and high frequency has almost a universal standard for the range of frequencies. But in ultra-high frequencies, each country has its own standard, and microwaves also have different types of frequency range. Protocols for communication between tags and readers are proposed by a number of bodies and equipment manufacturers. The two most prominent organizations for setting standards are International Standards Organization (ISO) and EPC Global. ISO/IEC deals only with air interface protocols, but EPC UHF standard deals with air interface protocols and data structure. ISO/IEC 18000 tags. This standard originally conflicted with the EPC UHF specification and the new EPC UHF Generation 2nd specification. EPC UHF Gen 2 tags use backscatter coupling and an HDX communication mode, allowing for read range of up to 10 meters with optimal orientation of the tag and reader. ISO/IEC approved several RFID standards, from animal identification to air interface communication parameters in different frequencies. Also, EPC Global have various types of RFID standards. What are the most common applications for RFID? For low frequency, typical applications are access control, animal and livestock identification, ticketing, laundry, supply chain management, vehicle identification, container tracking, asset management, waste management, product identification, and process automation. For high frequency, typical applications are access control, ticketing, library management, laundry management, supply chain management, vehicle identification, container tracking, asset management, waste management, animal and livestock identification, product authentication, process automation, pharmaceutical counterfeit. Ultra-high frequency typical applications are supply chain management and distribution logistics, express parcel delivery, airline baggage handling, asset tracking, vehicle identification, container tracking, access control, waste management, product authentication, process automation, and so on. And for microwave, typical applications are electronic toll collection and real-time locating system. Advantages of RFID are not damaged as easily and are reusable. Non-line of sight scanning, simultaneous automatic reading, labor reduction, enhanced visibility and forecasting, item level tracking, reliable and accurate, information rich, enhanced security, robust and durable. But its disadvantages are cost of tags and new infrastructures, lack of training and limited knowledge, immature technology, concern of return on investment, and lack of ratified standards. The represented graph helps professionals to use the best technology. For example, if a person wants to track containers, active RFID and GPS are the best technology. And for packaging, passive RFID and barcodes are the best. Finally, it should be said that the main goal of an RFID system is to store data on a transponder that can be retrieved with an interrogator through a wireless connection. We can conclude our discussion in 5 rows. RFID is an automatic way to collect information or data on products and places. With using RFID, you can track equipment, materials, and personnel. Identification performed in milliseconds. No line of sight required. Store unique ID information. Maintain historical information. Works in a harsh environment and no human error involved. RFID can help to improve efficiency and productivity. And finally, RFID can reduce operating costs, labor costs, and waste costs. In one word, smarter, smaller, cheaper, and faster are the recurring trends in computer-related technology. So it doesn't take much courage to predict the same for RFID. If there is any question or ambiguity about data on a tag or in a database, the frequencies, the selection of technology, identification or locating, outdoor or indoor tags, RFID inspection and monitoring, we can discuss it now. Thank you for your kind consideration. In the next section, we will discuss about a proposed system for automated management of construction materials. Thank you.